In reality, people don't use files to manage data. Files are they are useful for simple data that you want to persist. But if you really want to do some data store that has the ability to query, that has the ability to have a multi-users reading and writing to the same data store, then file will not help you. You really have to move to a database. Now, in database, you have many choices these days. You have the relational database, you have other alternative databases. One of such alternative databases happens to be a document-oriented database. And what's one implementation, famous implementation of a document-oriented database is MongoDB. Okay, and it is very popular choice for web developers, especially modern web development, because web development these days is more about JavaScript as a programming language and JSON as the data format. And document-oriented, as I explained last time, fits very nicely, where you can have a JSON document, just take it and persist it as it is, without going through the gymnastics of splitting it into tables and so on. You just keep it as it is, store it as it is, and retrieve it as it is, as one unit. Yeah? Now, this is the MongoDB database. I want to program against it. I want to read and write from this MongoDB using program, like using a JavaScript program. I don't need to start from scratch. I better use a famous library like many thousands of people are doing. And I showed you, I think, at least 500,000 downloads per week in this library. So what I do here, this is just a review what we've seen last time. So first of all, I have to go and say npm install mongoose, and then require the mongoose library in my implementation, in my server-side implementation. And then the second step I will do, I come along and start defining the schema of my entities. What I mean by the schema of my entities? The structure, the properties and their data types. And that's why you are putting now effort into designing your entities. Your efforts you put in now will pay off when you come to implement your entities to persist them in MongoDB database. From where you get the definition of the entities? From your class diagram. If you have put effort in your class diagram and you specify the property names and the data types, it's just a matter of typing them in. Yeah? So once you define your schema, the next step is you create a model based on this schema. This is how Mongoose works. So what a model is, the model will allow you to read and write to this data collection called store. So what I mean here, I create the schema, and then I ask Mongoose, please go ahead, create for me a class called store based on this schema. And this class that gets created, what do we call this class that is created? Is a model. And what do you use the model for? To read and write. So instead of writing my own queries myself, how to deal with MongoDB and learn the native API, like directly talking to MongoDB, Mongoose is doing this on my behalf, and it's giving me nice, very easy to use methods to read and write. So once I create the model, the next step, I go ahead and connect to my database, because you remember last time we discussed, database is something outside my program. It could be running on a separate server. So I connect to it, and then I start sending these queries, write and read queries, read and write queries. Yeah. So this is an example here of how to connect. I connect and give it the server name, the database name. And here I use the model that I created to start reading and writing. For example, if I'm interested to get all the stores, I call the method find, and I pass an empty object, which means in this case, I'm not putting any filter. Go ahead and give me all. Yeah. So this is what you need to learn. If you want to use Mongoose to to read and write to your MongoDB database, two skills you need to learn. The first skill is how do you create the scheme. The second skill is what are the methods you should use to read and write, to query and to save and to update and to delete. That's all the skills. This step and this step is a one-line step. It's not important. Okay, you just learn it once and use same thing every time. What is important is to learn the schema and to learn the query methods. That's all it is. And to do this, we went through and saw some examples. Hopefully you already recall them. I'm not going to go through them again. This is just an example of how the schema looks like. You can keep it as simple as the lazy developer do it. This is the lazy boy. Just put the attribute and the type. This is the perfectionist developer. And they will say, okay, the type is string, this is required, trim it when you get it, and this is unique. Of course, this is the better way of doing it. The title, yes, it is required, trim it, because users might put some space at the end. I don't want the space at the end or space in the start. Trim it for me before you store it. Authors is an array of strings and so on, yeah? In here, reviews. Can you see here reviews? Reviews, what is the type of reviews? Can somebody tell me? What's the type? It is, first of all, an array, which means a book has one or many reviews. What is the structure of each review? It is defined in another schema. So each review will have 4 attributes. What are these 4 attributes or properties? Author, the rating, and the rating cannot be other than these values from 0 to 5, and it is required. And then the review text, which is a string, and the created on is date. And even if you don't put it, if you don't give the date when you insert in a review, it will be auto-added. And what will be the value? The date now. You see, it's very, very powerful.
So it's like an array of objects.
In here, this is the structure of each object. And in the schema of the book, it is an array of objects. Yes, it is an array of objects. But I have to tell Mongoose what is the structure of that object. Is clear? In here, I am embedding the definition directly because it is simple. But in here, because the definition of a review is complex, I define it outside and then refer to it in the big schema. Is clear this? Now, there's one more thing here. There is a store. Can you see the store, how I define the store? The store is an object ID. It is an ID referring to the store model, which is the store collection. So basically, I have the stores stored in another collection, which is the store collection. And then what I do here for the book, I add a reference to the store. And by the way, the store is not a simple store. It is an array, because a book can appear in different stores. Yes, please.
For the review schema,
yeah.
The array is inside, but the array symbol is inside, but for the store it's outside. Like here the type.
Yeah, I see what you mean. Okay. Yeah, that's good point. Good point. Maybe we can do it this way. Like, I guess both ways are fine, I think. But in here, I guess it's more meaningful to put it this way. Yeah, because this default is for the reviews, which means if you create a new book, I will not add the Mongoose will not add the reviews property. By default, it will not appear. When it will appear, when you add a review. I think it's alternative, but I haven't played with it. But this is good point. Yeah. But in fact, yeah. But in here, I'm defining the whole type and then making it an array. Maybe we are doing this because of this special default. This is default of the whole attribute. Yeah. This is the default of the whole attribute. Anyway, yes, please.
How would I know if like a review is assigned to this book? Because there's no reference here.
Excellent. How do we know the review is associated with this book? How do we know?
Each book has the review schema.
Each book has a review schema, and also each book, the reviews are inside it. What's another technical word for this? Embedded. So the reviews are embedded in the document. So we have a document and we have an array of sub-documents. Yes? Now this design, these are two alternatives. This is the point I want to come to. Two alternative designs when we have a document and sub-documents. One design is to do it, which is the first style of design, what I'm doing here? Embedding. And here what I'm doing with store? Linking. Thank you very much. Two design alternatives. So when you get a design alternative, you have to have some kind of background to make the choice when to embed versus when to link. Why do you think we have embedded the reviews instead of linking them?
Because they're 100% related to the book, so I'll just go.
Thank you very much. So, you know the reviews, when somebody makes a review for a particular book, can that review be associated with another book? It is unique to that book.
Yeah, so it needs the book to exist.
Yeah, not only this, like we can afford to put it inside with the book as one unit, because that review, very unlikely we can link it to another book, or it doesn't make sense to link it with another book. While the store we have, let's say, 1,000 books, and we have, let's say, 5 stops. If we start embedding the store with the book, what will happen?
Redundant information.
We have the redundant information, which is fine. By the way, in document-oriented, some redundancy is tolerated. It's not a big problem. Space, because sometimes the convenience and the speed is more important. But in this case, because the store details can change. You know, sometimes the store moves. The address can change. The phone number can change. Yeah? So if we embed it in 1,000 books, we have to go and change it in 1,000 books. But if we link it like this, and we have store change, how many times or how many places we have to change the store details? 1. So what is the guideline here? When do we embed, when do we link?
Depends on the class diagram when it comes to many relations. For example, a stock can have many books, like a review, this book, our book.
Okay, very good. Yes.
One is
Very good. For example, one-to-one, it could be embedded, and that one-to-one is not shared. For example, customer and addresses, for example. More likely than not, the addresses are unique to that customer. We might have some brothers or family members living on the same address, but that's not very common. It doesn't matter. We will have some slight little duplication here and there. It's fine. Yeah. But in most cases, in 96 or 98% of cases, the addresses are unique to that customer. So we don't link them, we embed them. Okay? But things that are shared, we can link it to multiple documents. What we do? We reference them, we link them. Now, in terms of advantages and disadvantages. So what is the advantage of embedding?
It's only assigned to this, the embedded class or model. It's only unique for this.
Yeah, I mean, you're now describing, but you are not giving the advantage.
The speed, basically, you don't have to go.
Thank you very much. The speed. In one place, in one query, you go and grab what you need in one query. With linking, what happens? Multiple queries to bring the documents back together. So for example, here, when I get the book, I have to do another lookup in the store to get the store details. But if it was embedded, once I get the book, I get everything. So in terms of speed of querying. So sometimes if you really care about the speed in some use cases, you might go with duplication. It's fine. Yeah. Because sometimes you know, when you are building a system, you have quality trade-off. You are trading off maintainability with speed. If performance and speed is critical for a particular use case, let it be. You can embed. But as a general guideline, so if the object is unique to, sorry, if the related object or subdocument is unique to the main document, you embed it. If it is shared among multiple documents, you link it. Yeah? These is in high level the guidelines. And be aware that embedding in terms of performance is much better than linking, because linking will have more processing and more query time to get the whole document. Is so far clear? Okay, now, once you do the schema, once you create the model, it's time to learn how to do the queries, and we went through some of this. So once you build the model, now adding and updating and querying becomes super simple. So if I want to add, I just get the store and go ahead and create it. And by the way, let me show you usage of this. So if I go here and find usage, here it is. When I'm adding, this is a normal object. It's nothing fancy here. It's a normal object. Can you see it? Name and city, that's it. I take this object and ask the database to store it. That's all it is. So there's nothing really fancy here. Although I have the schema and all this stuff, schema is just to help the Mongoose to do its job. But when I'm adding and retrieving, at the end of the day, they will be plain JSON objects, plain objects, plain JavaScript objects. Okay, so that's what store is. Add. So this is find. We went through this before, if you recall. Here, find. I'm not putting any parameters here. It will get all. This is if I just want to count. This is if I want to get distinct categories and so on. Now, this is a more interesting example here. Sometimes this parameter is optional. So let me show you the end result of this. If I go to this one, if I do /API/books, I am getting all the books. This one, the category of this one is fun. The category of this one is programming. Can you see here? I'm getting all the categories, the books from all categories. Now, optionally, it's not obliged. I can supply here a parameter, category fun. And in here, I only get in 2 books in this case. Yeah. So this is optional. So how do I implement this optional filter in terms of repository? So I accept a parameter here, category, and then what I'm doing here, I'm defining a query. By default, the query will return all, by default. Now, if the category is not an empty, you supplied something, it is not undefined, it is not empty, what I'm doing, I go to this query and say, oh, the query now, I'm adding a where condition. But this where condition is only added, in which scenario do we add the where condition? If the category was passed. If I call getBooks, if I call it without supplying the category, that part will not be executed, of course. Okay, sorry, here it is. Sorry, just one second. Okay, now what this is doing, we discussed this before. What this line is doing, populate store. I'm going to the query and say populate store. Yes, you remember the linked subdocuments? Now, before I retrieve the document and send it to the requester, I ask Mongoose to go ahead and replace the references with the actual object. So instead of just having a store ID, which is meaningless to the end user will get the full store details. So physically, you are storing it as a link, but after the query, what are you doing? You're replacing these referenced objects or objects IDs with the actual objects. You're kind of converting linked subdocument to embedded subdocument. And then you return the query. This is the power of this. So you can customize the query based on the parameters. That's how you do it. So you don't need to have so many methods. Get books by category, get books by page numbers. You can have one method, you can pass the parameters. And based on the parameters you are passing, you can customize the where condition. And then you return the query. So what I mean, I just want to show you this populate. What's the role of this populate? If we come here, you see here the store. You see the store here? It's an object. It's an ID referring to the store collection. But when I'm getting at the at the end user side, the store, can you see the store? Is the full details of the store. Who replaced the IDs with the actual object is that populate call. And I put the populate and I pass as a parameter the name of the attribute. Of course, behind the scene, we can imagine Mongoose doing multiple queries to collect the whole data. Of course, in terms of execution time, it will be much slower than embedded document. Okay, so moving on. Yes, please.
Is the bind method synchronous function?
All this is asynchronous.
So why not using it?
Basically, what I'm doing here, I'm returning a promise. Okay, and on the service in here, I'm returning promises. I'm not returning the results. I'm returning the promises. And take a look at the service. This is good question. In the service, I am doing the wait. I don't need to waste my time do wait here and do wait there. Basically, when I'm doing the queries, I'm returning a promise. Who will do the wait? The service in our scenario. Yes, please.
Doctor, in the query project, query object, when we have it, can you go back?
Yep.
Yes. When you say book.find, we are
Yes.
actually getting the all the books in the query, right?
No.
Not yet.
You need to be careful here. So far, I am defining the query. I have not executed yet.
Where is it executed?
Up to here, it's not executed. Up to here, it's not executed. When is it executed? Here it is, in the service. When I say this get book and do wait, then at that time will be executed. So what I mean here, up to here, sorry, it is. Now up to here,
Okay.
at this stage, populate and return the query. No, sorry, let me, just a second. Like the other one I showed you.
Let me get book.
Where is get books? Get books, yes, it is get books. Yep. So far is not executed. So up to here, basically when I'm returning the query, I'm returning the query. At this stage, yeah, it's a bit, so definitely here is not executed. Here it's not executed. Here it's not executed. At this stage, I guess it will be executed at this stage. And then the caller will wait for the result. So what I mean here, when I do it find, I'm not getting everything to the client and doing the filtering. No. It will be done on the server side. Yeah, that's basically the idea. Many ways of doing these things, by the way. This is just one way of doing it. Okay, so let me go back. Okay, some more examples. In here, if I'm looking up by ID, and by the way, we already discussed this last time. Every time an object, a document is added to MongoDB, MongoDB will auto-generate this underscore ID, which is a unique identifier for each document. Now, if I want to look up a document by ID, which method should I use? Find by ID, and I provide the ID. And by the way, the ID is this one. This is the one I'm talking about. So in here, I could come to book/this ID and give me that particular book by this ID. And this result is coming from this method here. find by ID. Now, by default, if I stop here, I will get everything. But if I wish, I could limit the columns that I wish to return. Or another way of doing it, I can say return everything except these two by putting minus in front of them. That's a very powerful feature. Okay. What else? This is a little bit more sophisticated query in here. I'm asking for all books where one of the authors happens to be the author I'm passing here. So I'm doing an in condition. Now for updates, one way to do the update, I get the object, the whole object I want to update, and I ask, please go ahead and update this book, and this is the new definition of this book. Of course, the new definition should not have an ID, underscore ID, because the underscore ID is not changeable. So that's why I remove it before I pass it. Otherwise, I'll get an error. Yeah? So when it comes with the underscore ID. But before I submit it for update, I remove that underscore ID. Okay, delete, this is the delete, super easy. You just go for model, remove, and you give the ID of the book to be removed.
You delete the ID or the book?
Here you delete the whole document.
No, I mean the update.
The ID, yeah, I only delete the ID, the underscore ID. Yeah? Before submitting it to the database.
It's possible to have a book without an ID?
No, basically what I'm saying here, take a look at this. I'm asking the model, please go ahead, take the existing book with this ID and replace it, all the fields with this new book documents I'm giving.
Except the ID.
Yeah, except the ID. Yeah. But in here, because I cannot, because if it sees the ID, it will try to update it and it will cause an error. That's why I remove it. Yeah. Now, remember I have a review, I have a book and I have a sub-documents of reviews. So how do I add a sub-document to an existing document? So take a look at this. I'm asking here, go ahead, go to this book and add this review. So first I retrieve the book, go to the reviews collection, push the new review and save. Now if I want to update a review, I have three things here. This is my book ID, this is the review ID, and this is the updated review. So all I'm doing here, one way of doing it, I get the book, I get the review with this ID, updates these two attributes, and then save it. Okay, the last thing I want to show you is aggregation, aggregate queries. This is very, very powerful and very much needed in realistic applications, because in most realistic applications you have some kind of reports that aggregates. Aggregation means, so for example, I'm not interested in your GPA of each of you. I only want to get an idea about the average GPA or average age. Or for example, in your project, you have a summary reports. For a particular week, how many jobs did we finish? How many kilograms or tons have we processed? How much money did we collect? As aggregates. Yeah? So to do it using files is a big job. That's why I didn't ask you to do the reports implementation in phase 1. You will do it in phase 2. And you will need to learn this query language. It looks complicated, but I will explain it. It's very easy once you practice with a couple of examples. Okay, so let me show you very quickly. So in here, this is an IDE. There are many IDEs or development environment to interact with the MongoDB graphically. One of them happens to be called MongoDB Compass. This comes from MongoDB team. When you install MongoDB, one of the options that will give you tick box to install this IDE. And one of the tools it gives you, of course, you can come here and do your queries here. So let me show you an example. So for example, here, category, fun. See here I have 5, but if I find maybe I have to put this, maybe, yep. Yes, you see here 2. So basically the same syntax as the Mongoose. So basically you put a curly brace, the name of the field, colon, the value. Let me put, let's say 200. How many? 3. 3 books with the pages greater than 250. See here, you see the query, how it looks like? This is the name of the attribute, and this is the condition. Greater than, and this is the value. Okay, so you can do the query like this. And by the way, you can also, I think, export to a language. This is how you do it natively here in this IDE. Export to a language, you put node, and this you can have your query like this. You copy paste this in your find. You remember you have a find, model.find, you copy paste this. It will run for you if you wish. Anyway, this is not what I want to show you. More importantly, I want to show you the aggregates. So in the aggregates, the aggregate, the way it works, let me show you through this super quickly here. It works like a pipeline. Let me very quickly here. Here it is. So it is a stages, multi-stages query. So for example here, I am first filtering the customer where the status is A. The results of this stage will be fed to the next stage. So this is the results of this stage. It will only give me these 3. This one will be excluded. Then the next stage, I am grouping by customer ID. Can you see here the customer ID? And getting the total amount. So this guy has ordered from us 750, and this one is 200. So aggregate queries work using a pipeline, which means a multi-stage query. Each stage produces some intermediate results, and these results are fed to the next stage. Multi-stage, and at the end you get the result. Okay, so let me show you. What I will do now, and let me change this. I will change it to group. Here is group. So what I need here is which field I want to group by. The field I want to group by, I assign it to this underscore ID. So for example, let's say I want to group by category. And what I want to do, I want to get a new field. I call it average pages. And this average pages, the way I will compute this average pages, I will use the average function. And which attributes I will be using? H pages. Let me give it a try. Maybe this one is like this. Yeah. Can you see what's going on? It's a little bit, the query language is a bit cryptic and a little bit of getting used to, but it's very, very powerful. So how do I specify which column to group by? Assigning that column name to this underscore ID. This will allow you to specify the group by column. Now, what are the results? What things I want to aggregate? In this case, I just want to aggregate the pages, and which function I want to use to aggregate them? The average. So this gives me that the programming people, they write lots of boring stuff and they go on and on. 318 is the average. While the fun stuff, they run out of ideas much quicker. They stop at 200, that's the average. See, it's very simple once you get used to the syntax. I assign kind of this, the attributes I want to use for aggregating grouping by, I kind of assign it to the ID, underscore ID attributes. And then I define the new columns I want to compute. In this case, how many new columns I want to compute? The average and the count. How do I compute the average? Is the average of pages. And how do I compute the count? is by summing one, give a kind of assigning one to each book, and it will be nice to have a count, but the count is a separate. You can have it as a separate stage if you wish. Okay, not only this, what I can do here, I can go ahead. This is the first stage, I'm grouping. And then the second stage, I want to sort. Can you see here, sort? And basically in here, I want to sort by pages -1. Pages -1, let me sort by pages 1, from small to big. I was expecting, no, not pages. I want average pages. Can you see there? Yes. Can you see average pages? This is the sort by average pages. 200, then 300. If I sort by count, can you see here? It will be this plus this. If I do -1, it will be descending order. So the bigger ones than the smaller ones. Yeah. So this is a multi-stage query. The result of this is fed to this operation to produce this. It's a multi-stage, and you combine them. One way to do it, you test this visually and you play with this query. And then once you are happy with it, you can go ahead here, export to a language, and you do, for example, Node. And this is basically your query. You can take it, you go to you go to your Node.js, and you have here book.aggregate, and you can paste it here. You can paste it here. And let me just rerun, for example, this guy. Here is the app. Rerun this. I think, let me see the route. Yes, it is under report/summary. Under report/summary. And I get exactly the same as what I got here. Remember, 3 and 2? 3 and 2, yeah, exactly the same. So it's a very nice IDE where you can test each stage, you're happy with it, and then you can just go here, export to language, and then you copy this, like for example, no, choose your language, copy this, and paste it into this one. This is the book repository. In here, basically what we are doing, book.aggregate, and you put an aggregate query. Yeah.